AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum dan selamat petang semua. Selamat datang ke Pusat Tuisyen Percuma, Akademi Youtuber. Bermula percuma, selamanya percuma. Apa khabar para guru, ibu bapa, terutamanya pada pelajar-pelajar yang dikasihi sekalian. Di mana jua anda berada, kami doakan anda sentiasa sihat dan sejahtera. Jadi bersama lagi kita pada petang ini untuk mengikuti satu lagi kelas tuition online percuma di Akademi Youtuber dibawakan dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okey, baiklah anak-anak pelajar semua, sebelum kita mulakan kelas pada petang ini, mari kita mulakan dengan umul kitab dan doa belajar. Manakala bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya Rabbal Alamin. InsyaAllah mudah-mudahan kelas kita pada petang ini berjalan dengan lancar dan sekiranya anak-anak pelajar ada soalan yang ingin dikemukakan kepada presenter kita iaitu Mr.Peh, anda typekan saja pada ruangan live chat di bawah. Okey, jadi sebelum kita mula, mari kita kongsikan lagi link kelas kita pada petang ini. Kita sebarkan lagi supaya sama-sama dapat manfaatkan apa yang bakal dikongsi oleh Mr.Peh pada petang ini. Okey, baiklah, saya perkenalkan dulu barisan guru-guru yang bertugas di konti pada petang ini. Saya sendiri Cikgu Hasnitah sebagai moderator, kini berkhidmat di SMK Bagan Jaya Butterworth Pulau Pinang. Dan kita ada presenter kita tidak lain dan tidak bukan di sana, memakai t-shirt AYU di sana, Mr.Peh ataupun nama dia Cikgu Peh KH yang kini bertugas di Kolej Tingkatan 6 Tun Fatimah Melaka. Apa khabar Mr.Peh?
Khabar baik, cuaca pun baik di Melaka.
Cuaca pun baik di Melaka. Okey, Alhamdulillah. Okey, jadi sekali lagi kita alu-alukan ke tangan pelajar, kongsikan lagi link kelas kita pada petang ini, dan siapa yang belum subscribe kepada channel Mr.Peh, anda boleh klik pada butang subscribe sekarang dan berikan sokongan kepada Mr.Peh. Jadi anda akan menjadi orang yang pertama menerima notifikasi bila masa Cikgu Mr.Peh adakan kelas secara langsung ataupun memuat naik video-video PDPC yang terkini. Okey, baiklah, cikgu tak ingin membuang masa lagi. Jadi kalau anda semua sudah bersedia, Mr.Peh pun sudah bersedia. Jadi ayo kita mulakan kelas kita pada petang ini. Silakan Mr.Peh.
Okay, so terima kasih Cikgu Hasnitah. Okay, so ini merupakan kelas fizik minggu untuk fizik. Okay, so untuk kelas tingkat 5, sekarang kita sudah sampai subtopik 2.6, prinsip bernoli, dan disampaikan oleh Cikgu Rina Rashid dan diadakan pada setiap hari Jumaat 9.30 malam. Dan untuk tingkatan 4, kelas diadakan seperti hari ini, hari Ahad 3.30 petang, dan tajuk akan sampaikan hari ini adalah weight. Okay. Ini merupakan panitia Fizik SPM Akademi Youtuber Malaysia, dan hari ini bersama saya ada Cikgu Hasnitah, di mana kita akan sentiasa bersama anda. So kita berharaplah semua pelajar boleh joinkan kelas kita secara percuma, dan kita pun sentiasa memberikan sumbangan yang terbaik kepada semua. Okay, so I am Mr.Peh. Currently I am teaching at Oleh Tingkatan 6 Tun Fatimah Melaka, and today I am going to teach the last subtopic for chapter 2. So the chapter 2, Force and Motion 1, the last subtopic will be weight. And the learning center for today's lesson will be only one. So is to describe weight as the gravitational force that act on an object. Okay, so before we go to the syllabus Form 4, so this is better for us to recall some of the concept of gravity, which is you already learned in PT3 level. So from Form 2, Science Chapter 8, Force and Motion, you actually already know the meanings of gravitational force. The gravitational force is act towards the center of Earth. You can look at the figure. So all the object will be added by gravitational force towards the center and causing all object fall on the earth, just like the apple will be fall from the tree. And then the gravitational force will cause the planet revolve around the sun, just like the figure. Besides that, from Form 1 Science Chapter 1, Introduction of Science Investigation, you have already know that the instrument that can be used to measure the weight will be compression balance and spring balance. And the experiment regarding the weight will be normally using the spring balance to measure. Okay, so now we go to the definition of the weight, which is the learning standard one you need to be understand. So the definition is very easy. So weight of an object is defined as gravitational force added on the object. So that means the weight will be equal to gravitational force. The weight is a vector quantity. This because the weight consists of magnitude and also together with direction. And it has the same direction with the gravitational force that is towards the center of Earth, just like the figure I show you here. And then we go to the one and only formula for this subtopic, the formula of weight. So firstly, you have to understand the terms or parameter involved in this formula. So here an apples of a mass m is released and free fall with gravitational acceleration. So gravitational acceleration, we already know that they will be equivalent to 9.81 meter per second square, where you learn at section 2.3 already. The only force adding on the apple is its weight, which is downward. You can look at the GIF here. Okay, so to understand the formula of weight, we need to apply the Newton's second law of motion. The formula will be F equal to ma, and here the F will be referring to weight, which has the same unit as Newton. Okay, for force and weight. And the A will be referring to gravitational acceleration, G, which is equivalent to 9.81 meter per second square. So W represent as weight, N represent as mass, and G represent gravitational acceleration. And here in this subtopic, the G is not only referring to gravitational acceleration you learn at section 2.3. And here the G can be referring to gravitational field strength. Okay, so what is the gravitational field strength? Okay, so from the formula W equal to mg. So when we rearrange the formula, G equal to W over M. So where the W is equal to weight and equal to gravitational force. If we are referring to the definition of the weight, which is a gravitational force added on an object. And the M referring to the mass, and here will be per kg. Therefore, the definition for the gravitational field strength can define as gravitational force per kilogram. So you can just remember the definition for gravitational field strength by rearrange the formula, weight formula here. Okay, so the SI unit for gravitational field strength will be, you can look at the formula, the W SI unit will be Newton, and the mass SI unit will be referred to kg. So we get the unit SI for gravitational field strength will be Newton per kg. Okay, so our weight is actually slightly vary from place to place. Okay, because the G is slightly different at different place on the Earth, and it is actually depends on two factors. First will be the latitude. So what is the latitude? Okay, so you can refer to the image of the Earth here. So the Earth is actually not a perfect sphere. And from this figure, you can see the diameter, the polar diameter is actually shorter compared to the equatorial diameter here. But the difference is slightly different only. Okay. However, we can conclude that here the RP here I refer to the radiance from the center of the Earth to the pole, and the RE will be radiance from the center of the Earth to the equator. Okay, so from here, the radiance of the equator is actually greater than radiance of pole here. Okay, you can refer to this figure. Okay, so from here, the GP referring to the gravitational field strength at pole, while the GE referring to the gravitational field strength at the equator. Okay, so you can see the distance of the pole to the center is actually closer compared to equator. Therefore, the gravitational strength is actually at pole is slightly greater than the equator. Okay, however, overall we're still using G equal to 9.81 on Earth. Okay, so if let's say we compare the gravitational field strength at North Pole to KL, okay, our capital city of Malaysia, which is located at equator. So the G is greater. So that means when you weigh, okay, you weighting your weight, so will be slightly higher expected compared to you weight your weight at North Pole. And then another factor will be altitude. So it's referring to the height above the sea level. Okay, so from this figure, you may see that with higher altitude, the value G, which is the strength, gravitational field strength is lower compared to sea level. Okay, so again, this is because at the sea level, so we are closer to center of the Earth. Okay, so here if I say we compare to Kota Kinabalu with the Mount Kinabalu. So the Mount Kinabalu, the gravitational field strength will be lower as it is more further to the center of gravity. Okay, so here we can conclude that G will be decreases when object further from the center of Earth. And this will be the relationship which you are going to learn in next chapter. Okay, G is inversely proportional to R squared here. Okay, so from here we are clear that when the object on the surface, if the distance is greater, so the G will be decreases. okay, which is same meanings which I explained just now regarding the G and North Pole and at the equator. However, overall the G is actually slightly different. Okay, and then here, deep in space is free from any gravitational pull, so our weight will be 0. So that means here in space, the G is actually 0. Okay, and then the weight, the formula will be W equal to mg. When G is 0, so the weight will be 0. And then the next, we compare the gravitational field strength on the moon to the Earth. So the gravitational field strength for the moon is 6 times lower compared to the gravitational field strength on Earth. Okay, so here is a summary comparison of the mass and the weight for these 3 different locations. So where the first will be deep in space, second on surface of Earth, and then the third one will be on the surface of the moon. So from here, you can see that the mass will be always constant at this different position, okay, this different location here. While for the weight, with this formula, W equal to mg, so the G will be affecting the value of the weight. So at deep in space, as per mentioned just now from sentence number 4, the G will be 0. So when G is 0, so the weight will be 0 in space. Okay, and then for the Earth, here if let's say we assume that the overall gravitational field strength on Earth is equal to 10, okay, so with this formula, mass 100, with G is 10, the value will be 1000. Then the last one, the weight on the moon will be going to 6 times lower, as the gravitational field strength on the moon is 1/6 to gravitational field strength on the Earth. So we'll be going to smaller value of weight if we are located at moon surface. Okay, and then the next here, I would like to compare the differences between the mass and the weight. Okay, so here, the first definition for the mass will be the amount of the metal in the object. For weight, just now I already explained the definition. There will be force of gravity adding on the object. So the weight will be have the same meanings of gravitational force. Okay, so second for the magnitude, so the mass will be always unchanged. Whether in this space, moon or the Earth is always the same. Just now I already showed you, which is equivalent to 100 kg in the table I showed you in the previous slide. Okay, and then the weight will be different depending on the gravitational field strength at the location. For example, just now, the gravitational field strength for the moon is lower than the Earth, so that means the weight will be lower compared to on the Earth. And then the quantity, mass is scalar quantity, so it will be only magnitude, but do not have any direction. While for the vector, just now I mentioned to you, they will have a magnitude, and the direction will be towards the center of Earth. Then SI unit for the mass will be kilogram. You already learned in Form 1, Chapter 1. And the weight will be Newton. Okay, so this is part I finished for subtopic 2.8. So later on, we'll continue discuss the question. Okay, I pass back to moderator Cikgu Hasnitah.
Okey, baik. Terima kasih Mr. Peh. Jadi para pelajar semua jangan ke mana-mana, kita berhenti rehat seketika, kembali lagi selepas ini. Okey, baiklah. Selamat datang kembali ke kelas tuisyen online percuma di Akademi Youtuber. Petang ini anda sedang mengikuti kelas tuisyen online secara percuma, siaran langsung dari dua channel sebenarnya kita bersiaran pada petang ini. Yang pertama, channel utama kita iaitu channel presenter Mr. Peh, dan yang kedua channel saya sendiri Cikgu Hasnitah. Jadi anda teruskanlah berikan sokongan kepada kami, dan sekiranya anda belum lagi memuat turun aplikasi Akademi Youtuber di Android anda seperti yang dipaparkan dalam iklan tadi, anda boleh berbuat demikian hari ini juga, kerana di sana kami ada lebih kurang 24,000 video PDPC yang boleh dimanfaatkan membantu anda dalam PDPC. Kita ada video-video daripada prasekolah sehinggalah pra-universiti. Jadi semoga video itu tadi semua memberi manfaat kepada semua. Jadi kita teruskan kelas kita pada petang ini. Silakan Mr. Peh.
Okay, so terima kasih Cikgu Hasnitah. Okay, so welcome kepada Horror. Okay, I just saw a comment and in the chat room. Okay, so let us come to our first question in today's lesson. Okay, so diagram shows a coconut falling from a tree. Okay, so you can see the coconut is falling from a tree. Which graph shows the relationship between the gravitational force acting on the coconut and the mass of the coconut? Okay, so this is a question in SPM 2009. Okay, so here you can look at the answer will be F to M. Okay, so here the gravitational force, the equation we are using here will be F equal to mg. So the g is always constant, okay, on the earth, which is have the value of 9.81 meter per second square. So from here, we are very clear that when n equal to mg, the m is equal, so the f will be directly proportional to m. So the answer here will be very clear, B. Okay, so you can join the discussion and show your answer in the chat room. Okay, and then the next question will be the question in 2010, question number 11. Okay, so let us read the question together. So diagram show a feather and a stone falling freely in a vacuum. So you can see here we have two objects, feather and a stone. Okay, will be in a vacuum. So which statement is correct about the motion? Okay, so the feather and the stone fall with the constant velocity. So here, the mistake will be at these words, okay? Okay, so here, let us look at the hot tips. Here, is given in a vacuum, both the feather and the stone do not experience any frictional force. This is the first info you need to know. Then second, both are pulled by the gravity with the same value, which is equal to 9.81. Just like I showed you already. So from here, the first statement will be wrong because it will be constant acceleration. Okay, and then B, the feather and the stone have the same kinetic energy. Okay. So here also wrong because referring to formula you learn in PT3, the kinetic energy will be equal to 1/2 mv squared. So the mass for the feather and the stone is different. So the kinetic energy will be different. Okay, and then the C, the feather and the stone reach the ground at the same time. Okay, so the answer should be C actually. Okay, because they both experience the same acceleration, and there is no any frictional force added to the object, so they will be reach the ground at the same time. Okay, so this is a question where also regarding the subtopic 2.3, free falling. Okay, then we look at D, the gravitational force adding on the feather and the stone are the same. This one also wrong because with formula W equal to mg. Okay, so when m is different, so different, this one is different, so the W will be different. Okay, so answer will be C. Okay, the next question, number 3, okay, will be the question in 2018, question number 10. Okay, so the question will be like this. Okay, so Kalim weight on Earth is 800. What will happen to his weight on the moon? Okay, this one also we discussed just now. Okay, so the gravitational field strength on the moon is actually 1/6 of the gravitational field strength on the Earth. So that means the G at the moon is actually smaller. Okay, yes. Okay, so Horror, you are correct. So answer here is B. Okay, good try. Okay, so with the formula W equal to mg, so you can see G is decreases at the moon, so the W will be decreases. So answer is B, correct? Okay, good try. Okay, so the next question, number 4. Okay, so it will be the question in 2019. Okay, so here an apple fall from the tree. Okay, you can look at the GIF. Which physical quantity remain constant? Okay, so this one will be also quite similar to previous question. So here the hot tips here will be the object will be 4 with G equal to 9.81. So that means here which will be constant. Okay, so will be G lah, okay, which is 9.81. Okay, so the answer here will be B also. Okay, and then the next question. Okay, question number 5. Okay, so the weight of an object on Mount Kinabalu is less than its weight at the Kota Kinabalu. Okay, why? Okay, this one I also explained already just now. Okay, so here A, it is colder on the Mount Kinabalu. B, Mount Kinabalu is in equator. C, Mount Kinabalu is further from the center of the Earth. D, the density of the object decreases on the Mount Kinabalu. Okay, if let's say you get the answer, you can share, okay, in the chat room. Okay, so here the tips will be like this. Now, just now also I explained already. Okay, so the G is depends on the height above the sea level. Okay, so here we compare two location. So the Mount Kinabalu will be at the high altitude position. Okay, and then okay, so good try. Okay, Horror, you get the answer C. Okay, so let us see whether it's correct or not. And then the Kota Kinabalu will be at the sea level. Okay, so here, although the Mount Kinabalu is also at equator, but the best answer here, the difference weight is due to the different altitude here. Okay, so the answer here is C, better. So Mount Kinabalu is further from the center of the Earth. Okay, so very good. Horror now. Okay, and then the next question, number 6. Okay, so this will be the calculation. Question number 6 and number 7 is calculation. Okay, so let us see what's the calculation we'll be going to ask in this subtopic. Okay, so the gravitational force adding on the object with the mass 800 kg and the force given as 5,000. So what is the gravitational field strength? So that means the question asking you about the G. Okay, so we'll be using the one and only formula in this subtopic, which is W equal to mg. Okay, W equal to mg, and then we just rearrange, then we get the value of g. Okay, so which is equal to 6.25 Newton per kg. Okay, so the unit for the gravitational field strength will be Newton per kg. And you have to give answer minimum 2 decimal places. Okay, so this is a very straightforward question. Then we go to the next, is also the calculation. Okay, so the question will be like this. An object weighs 100 Newton on the surface of the Earth. Okay, and then if it weighs 150 Newton of a planet, so what is the gravitational field strength here? So again, the question asks you to find out the G, but the G is at another planet. So you can put as GP. Okay, so here we also using one and only formula. So what is actually the info, okay, the knowledge you have to know? So the object with the different weight at different planet, but with the same object, they will have the same mass actually. Okay, so here you need to know the value n is constant. Okay, so if I said you get the answer, you can share at the channel also. Okay, so firstly, we know already at Earth, the G is equivalent to 9.81. Okay, so we're using the first formula, W equal to mg. Okay, so where the WE referring to weight on the Earth, and GE referring to the gravitational field strength on the Earth, which is equal to 9.81. Okay, so we will get the value n, which is equal to 10.19 kg. So the object with the mass will be same when moving to another planet. Okay, so here we're using the same formula, but here WP referring to the weight of the object at the planet, and then GP here referring to the gravitational field strength at the planet, and we need to get the value. Okay, again we will range, we get the value equal to 14.72 Newton per kg. Okay, so I hope you understand the concept. Okay, then we go to our last question. So here will be the question number 8. So is the question paper 2 comparison. So conception will be question number 5 or 6. Okay, so here, okay, so the diagram show a feather and a piece of the coin drop from the same height in the vacuum. So you can see at the figure, initial position, both of the object is at the same height. Okay, so firstly, the question asks you regarding the meanings of the weight. So I already give you just now. So will be the force of the gravity acting on the object. So this is the learning standard 1, the definition you need to memorize here. Okay, and then the second question, B, based on the diagram, compare the mass of the feather and the coin. Okay, so we already know in logical thinking, right? So the coin will have a greater mass compared to feather, this one. Okay, so you can just give the answer, feather less than coin, or vice versa. Okay, then second, compare the weight of the feather and the coin. Okay, so here W equal to mg, G is equal, then M here, shilling will be greater. So that means the weight for the feather will be less compared to coin. Okay, so you can give the answer feather less than coin. Okay, and then the next question, number 3, also the conception question. Compare the time taken to reach the ground. So from here, you can see initially, both is at the same position. And at the end, they will be also at the same position. So that means here, they will be reach the ground at the same time. Okay, so the feather will be equal to coin. Okay, then C, based on the answer in B, state how the mass affect the time taken to reach the ground. Okay, so from here, number 3, we already know that the mass will be not affecting to the time taken. So because both objects have different mass, but reach the ground at the same time. Okay, so here, the mass does not affect the time taken to reach the ground. Okay, and then the next, state the relationship between the mass and the gravitational force. So here, just how we already know that the gravitational force referring to the weight. So that means W equal to mg. When m increases, the W will be increases. So here, mass increases, gravitational force will be increases. Or you can give the mass is directly proportional to the gravitational force, which is same as the objective question number 1 we explained just now. So the graph will be like this lah. M and F. Okay. Okay, then name the physics concept to describe the situation. Okay, so this one we already learned in section 2.3. This one actually. So will be free fall. Okay, and then we go to our last question for today's lesson. Okay, so E. So what happened if the feather and the coin are not dropped in vacuum? So discuss the reason. Here, 2 points you have to given because the mark is two marks here. So what happened will be first mark, reason, another mark. Okay, so here you can see with vacuum, the both object will be dropped on the ground at the same time. Okay, due to there is no any frictional force. Okay, but without the vacuum pump, that means there is an air, okay, inside the glass tube. Okay, so the frictional force will be give a bigger impact to the feather compared to coin. So the coin will be dropped on the ground first. Okay, so the first mark will be the coin will reach the ground first. Then second, you have to give the reason. Just like I showed you already. I explained to you already. Okay, it's due to the air resistance adding on the coin is smaller. Or you can give due to the air resistance adding on the feather is greater. Also can. Okay, so you'll get your second mark. Okay, so that's all for my sharing today. Okay, so thank you. Okay, I pass back to Cikgu Hasnitah.
Okay, thank you very much, Mr. Peh. It's a very vivid and crystal clear explanations with the related exercises and questions. And students, if you notice, some of the question discussed by Mr. Peh today is closely related with our content standard 2.3 free fall motion. So if you can understand free fall motion, so I strongly believe you won't have any problem in understanding gravity or weight as well. Okay, jadi terima kasih Mr. Peh, satu penyampaian yang begitu jelas dengan contoh-contoh yang mudah difahami dengan jawapan dan penyelesaian yang diberikan. Jadi cikgu harap sesiapa yang telah mengikuti kelas pada petang ini anda dapatlah pelajari apa yang dikongsikan oleh Mr. Peh tadi. So anda dapat manfaatkan dalam peperiksaan nanti. Okey, saya percaya ramai yang sini sedang bersedia untuk peperiksaan pertengahan tahun. Ada sekolah yang telah mula, ada juga yang telah tamat, ada juga yang baru nak bermula saja. Jadi manfaatkanlah masa dengan sebaiknya supaya anda tidak panik ataupun gabra semasa menjawab peperiksaan nanti. Okey, jadi Cikgu Peh, Mr. Peh, kita kongsikan dulu link sijil kita pada petang ini. So student, those who joining us, you may get your e-certificate as share in the screen now. Anda bolehlah klik pada link ini dan pastikan anda isi menggunakan email e-didik. Kalau tak ada email e-didik, anda boleh gunakan email MOE ataupun email delima dan juga boleh menggunakan email myjawi. Link ini boleh diisikan dalam tempoh 30 minit selepas kelas kita tamat bersiaran. Kita ada Harold tadi and di sini kita juga ada Lemonade and Lemon. Okay, thank you very much for joining our session this evening. So jangan lupa teruskan bersama kami minggu-minggu yang seterusnya. Ada banyak lagi kelas kita akan sampaikan mengikut standard yang ada di DSKP untuk silibus fizik tingkatan 4 dan tingkatan 5 untuk KSSM. Okey, jadi Mr. Peh ada sedikit kata-kata terakhir untuk petang ini nak dikongsikan kepada pelajar-pelajar kita, silakan.
Okay. Okay, so terima kasih kepada Lemon, okay, Lemonade and Lemon.
Yes.
Just join kita, okay. So harap semua boleh fahamlah satu topik yang sebenarnya sangat mudah. Okay, dan kita berjaya habislah satu topik untuk semua chapter 2. Okay, so coming next week, kita akan masuk satu topik yang lebih mencabar, okay, chapter 3. So harap lebih ramai lagi boleh join kita. So kita punya tuition ini percuma. Yang penting kita nak semua belajar, tak kira sesiapa, okay, akan ketinggalan. Okay, so kita sebagai cikgu kita sentiasa haraplah semua, okay, belajar boleh belajar. Di sini percuma, so tidak ada masalah kewangan lah. So harap boleh lebih ramai lagi support kita punya team Fizik AYU. Okay, thank you.
Okey, terima kasih Mr. Peh dan kita juga nak ingatkan anda boleh tonton semula kelas ini berulang-ulang kali. Okey, anda pergi saja ke pautan yang sama, just click the same link in Mr. Peh's channel. Okey, dan ada banyak lagi video di sana yang anda boleh ikuti kerana semua kelas yang kita adakan sepanjang tahun ini adalah dirakam dan anda kalau terlepas siaran secara langsung, anda boleh tonton kembali rakamannya. Kita juga ada playlist yang kita kongsikan kepada pelajar dan anda juga boleh tonton melalui aplikasi yang kita pada iklan tadi, iaitu anda boleh download di Android anda, nama dia pergi saja ke Google Play Store, anda typekan saja Akademi Youtuber dan boleh download apps ini dan anda boleh tengok video di sana yang telah disusun mengikut chapter, mengikut bab masing-masing, sama ada untuk tingkatan 4 dan juga tingkatan 5, untuk kelas DLP dan juga untuk kelas bukan DLP. Okey, jadi dengan ini kita tamatlah sudah bab 2. So we have finished with chapter 2. So for next week we are going to continue with the new chapter as mentioned by Mr. Peh just now for chapter 3.1 under gravitation is the theme. So for 3.1 Newton Universal Law of Gravitation will be represented by me, Cikgu Hasnitah. Saya akan sampaikan pada minggu depan. Jadi jangan lupa waktu siaran kita hari yang sama, waktu yang sama, Ahad 3.30 petang untuk tingkatan 4 kelas DLP, manakala untuk minggu hadapan kelas tingkatan 5 kita akan mula dengan tajuk baru juga, bab 3 iaitu bab elektrik 3.1 arus dan beza keupayaan akan disampaikan oleh Cikgu Rosemawati. Waktu siarannya adalah pada hari Jumaat 9.30 malam. Okey, yang itu adalah untuk kelas bukan DLP lah. Okey, jadi anda jangan lupa kongsikan kongsikan semua kelas kita kepada rakan-rakan yang lain. Mudah-mudahan semua yang menonton ini mendapat manfaat daripada ilmu yang kita kongsikan secara percuma saja, Mr.Peh macam Mr.Peh bagi tahu tadi. Okey, jadi sekian saja untuk hari ini. Saya dan Cikgu Peh mohon ampun dan maaf sekiranya ada sebarang kesilapan ataupun kekurangan di sepanjang kami kongsikan perbincangan pada petang ini. Segalanya yang baik daripada Allah dan sesungguhnya segala yang kurang itu daripada kelemahan kami sendiri. Jadi teruskan bersama kami dalam siaran-siaran kelas langsung seterusnya, dan anda jaga diri, jaga kesihatan, jaga keselamatan di mana jua anda berada. Kami sentiasa doakan anda berjaya dalam apa jua yang anda usahakan dan mendapatlah keputusan yang cemerlang dalam setiap peperiksaan yang anda duduki. Yang penting you get the knowledge, so the grade will come to you. Itu yang cikgu percaya, anda dapat ilmu itu, grade yang baik itu nanti akan datang kepada anda. Okay, so sekian dulu daripada kami. Jumpa lagi dalam siri-siri yang akan datang. Okay, Assalamualaikum dan salam sejahtera semua. Bye-bye.